Hello class! In this video, we are going to learn how to multiply and divide like terms. In the previous video, we learned how to add and subtract like terms, and we're going to use that knowledge to help us learn multiplying and division. So let's remember the last video, where when we have two terms, we have to make sure they're the same, when they have the same variable and the same exponent. So in this case, we have x and x, so good, our variables are the same, and we have a squared and a squared. So our exponents are the same. So we can add these together. And we add the coefficients. We get 2 plus 3, which is 5. And then x squareds come along. So we have 5x squared for this term. So now let's look at the second term. We have 2x squared plus 3x to the cubed. Now we have our x's. They're the same. But our exponents, one here is a 2 and one here is a 3. Therefore, we can't add those together. It just remains 2x squared plus 3x cubed. And there's nothing we can do to simplify this. Now, with multiplication, it's a little different. For multiplication, we need to make sure that they have the same bases. The exponents don't matter in this case. So here, we have an a squared times a b cubed. Well, there's nothing we can really do to this because our a and our b are two different terms. But here, we have an a squared and an a cubed. So what we do when we multiply variables, we always add the exponents. So we would have the a, we'd bring over one exponent, which is 2. Then we'll add it to our 3. And here we get a to the 5th. And we see that this makes sense, because our a squared would give us a times a, and our a cubed would give us a times a. So if we count up all these a's, we have a to the 5th, because there are 5 a's. Now we did this because they are both a's. Remember, when it's a b, we can't do it. So that is multiplication. Now let's look at division. The same thing applies. Where? The same thing applies where we cannot divide with different variables. Here we have an a and here we have a b. We cannot divide the a and the b cubed, so that would remain there. Here we have an a cubed and a squared, so we can do that since both of them have an a as a base. So the way we do this, our little formula for dividing, is we take the variable, or base, and we take the numerator exponent. So in this case, we have a 3. And now we're going to subtract it from the denominator. So when we're dividing, we subtract the exponents. So 3 minus 2, and here we would just get a. Now something I want to show you is when we have a bigger exponent on the bottom, we're going to get a negative number. So here, we'll take the numerator, because we always take the numerator first, take the numerator exponent, subtract it from the denominator exponent, and here we have a to the negative first. Now instead of leaving it in terms of -1, what we could do is put our coefficient 1 in front of it, because that's always there, and divide it by 1, since a number can always be divided by 1. Now, in order to make this look without the negative, all we're going to do is bring down our number, bring down our letter a, and we get 1 over a. So that's how we get our negative into the denominator and make it a positive. So now let's look. Here we have x to the 4th and y squared divided by x squared times y cubed. So now we can look at this in a different way. This could be the same as saying x to the 4th over x squared times y squared over y cubed. Splitting up like this shows us that we can cancel out the x's and the y's respectively. So this would equal our x. We'll do the exponent, we'll do the numerator exponent minus the denominator exponent. And then same thing with the y. So we'll have our numerator minus our denominator. So now this, we get x, 4 minus 2 is 2, times y, 2 minus 3, which is -1. And we remember our trick from before, where we have our 1's. Our imaginary 1's are always there. And we get x squared times 1 over y, which can also be written as x squared over y. And we see that we can't go any further because we have our x and our y, which are two different variables. Let's do one more example. Let's do 2x squared times 3x to the fourth. Let's do 3x squared. 3x squared times 2y over 2x times y. So let's see what happens here. So like we said before, let's first look at the multiplication before we do any division. Are there any terms that we can combine up here? Well, I see we have two x's, and look, they both have an exponent of 2. Therefore, we can multiply those first. So we have 2x times 3x. Well, 2 times 3 is 6. And x squared times x squared. We're going to add the exponent, so 2 plus 2 is 4. So here we have 6x to the fourth. Now let's bring down the rest. Times 2y divided by 2x times y. And see how I multiplied first before dividing because we're using our PEMDAS. So now, our next step here would be look at the common terms, the common base of the two divisions. So here we have two x's, and here we have two y's. So again, we can split this up as 6x to the fourth over 2x multiplied by the whole 2y over y. And now let's do our trick again. So this would equal, first, whenever we have division or multiplication, we're going to do the coefficients first. So 6 divided by 2 will give us 3. Then x to the fourth, so we'll put our x to the fourth, subtract our denominator exponent, we'll get 1, so 4 minus 1, and this will be 3x cubed. So now for our y, we have 2, so 2 is being divided by 1, so we just bring our 2, and then y divided by 1. Well, we have y, and so both of these exponents are technically 1, so 1 minus 1, which gives us y to the 0, so instead, just gives us 2. So here, we have 2x cubed, 3x cubed times 2, which actually, now that we have a constant with our term, we can always multiply our constant to our term. So 2 times 3 would be 6x cubed. And that's how we multiply and divide like terms.